Hey everybody, welcome to the next video. We've gone over what data in transit between parts of an application look like, and we've also gone over basic architectural choices about where the data is stored in the bits and pieces of what make up an application, and more importantly, where the logic goes that processes the data. So at this point, we need to take a closer look at data itself and how we're going to store it. And ultimately, the competition for any custom made application is basically a spreadsheet, because a spreadsheet is accessible, everybody knows how to use them. You don't need any sort of development, whether custom or drag and drop or easy or hard at all, to use one. Just open one, start a new file, and off you go. You can write your functions to do math and other basic calculations as you add data to the spreadsheet and accomplish a lot of things. You can even tie spreadsheets into cloud services and get data into and out of the spreadsheets. So why is this not good enough? The most obvious reason is these are relatively fragile. If one person is in charge of this, it'll probably be fine. But if three people are going to use it, the three people have to agree outside of the controls of the spreadsheet what they're allowed to do and not do. If you sort this wrong and some other external application or service is pulling the last line, well, you just screwed up your data. There's also a question of, on the most common implementation of this, which is going to be shared Google spreadsheets or shared Office 365 spreadsheets. There's not a lot of fine control over who can do what. You can allow people to just look at it, or you can allow people to modify all of it, and that's about it. If a person with write access to this spreadsheet deletes all the data, then you could restore the previous version from an hour ago, but you can't stop somebody with write access from doing something that might screw up your system that you've got put together before they do it. They either can delete it all or not. It's very rudimentary in terms of access control. So this is basically why people still use databases. There's also the fact that performance is going to be a question. This is 20 lines taken out of the nonprofit mentioned in the message object videos, volunteer pilot and aircraft owner database. All the data has been anonymized. These phone numbers are random, and these emails obviously don't work, and their last names have been changed. So, none of these people are real anymore, but this is what their data looks like. So this is pretty simple stuff. First name, last name, phone, email. Are they subscribed to emails that the nonprofit organization sends out? Yes or no? What type of aircraft they have, where their home airport, what their home airport's code is, what the registration number of their airplane or helicopter is, and these are just timestamps of what date they joined, and if their record in here has been modified, what time it was modified, and a unique ID. This is very simple stuff. So, how would this look if we got this out of a spreadsheet and put it into a database? It would be something like this. We would have a table that we would get user data in. Everybody would still get a unique ID, name, phone, email, their sign up date. We could probably have a modification date too, to add a timestamp if they're modified. And then the nice thing about spreadsheets, or databases in comparison to spreadsheets rather, is um, databases can be linked together in many interesting ways. For example, we could have just users and catch all the data that a user might have, and then we could have a separate table in the database, which would be like another sheet in a spreadsheet with multiple sheets, to say, okay, this sheet is just for pilots, and we'll keep the same ID that's from their user ID to keep these associated with each other, and then we'll put airplane specific stuff for each person in the pilot table. And then we have another table for non-pilots. I mean, that organization has ground volunteers too, to come in and take donations in and sort them and weigh them so they know how much they weigh, bundle them up to be loaded into airplanes. So we could have non-pilot users as well, which for them, again, we could keep their user ID to associate them with their main user row in the database. And then we have non-pilot information about non-pilot users. For instance, what location they're in. We might have multiple locations on the ground to pick stuff up and drop stuff off. So for a non-pilot user, they may be in a different location, whereas a pilot is all over the place in any given day. So this is how the data will look different in a database versus in a spreadsheet, but the database is much more rugged, for lack of a better word, in many ways. For example, if we look back at the spreadsheet, these phone numbers, most of them are just digits, but you can see the one at the top has got dashes in it. That's difficult to prevent in a spreadsheet unless you put some sort of logic in your sign-up form to strip out those dashes before it gets to the spreadsheet. Whereas the database, I can declare the phone field to be numbers only, no decimals, no letters, no dashes, no brackets, no plus ones, no parentheses, just a number, and the database will enforce that for me. I don't have to worry about people putting in garbage data because the database will refuse to accept garbage data. Similarly, these codes for aircraft types, I could say standardize these with a function in the database that looks at these as they come in and says, if somebody puts a dash in this or a dash in that, then what we really mean is the one without the dash. I could put a filter or function in to correct these if they make minor mistakes in those. The modern versions of most databases also have georeferencing support. So I could say if I added a map package and plug in to my database, I could, without calling any external service, tell it to, hey, look up where 52F is and give me the latitude and longitude of that airport so I could put it on a map. I could also say, draw a circle on the map within a certain radius and say, give me all of the airports within that radius. And tell me if any of my pilots have been to that airport in the last 30 days or in the last 30 hours. Maybe I lost track of somebody. I need to find out where they stopped and I don't know where they are. You can do all of these complex filters, calculations, functions with databases, whereas with a spreadsheet, you pretty much just have a dumb storage medium that holds stuff that you might use something else to process it with, but it can't do any of this stuff on its own. The database is also going to be more performant as this grows. I've got 20 people here. When our nonprofit started in 2017, we had a couple of hundred people in the first few days with a couple of hundred airplanes, and we weren't keeping track of people on the ground at all. So a spreadsheet was okay in those first few days because we had 200 lines. But today, now that this organization's been around for 3 years, they have more like 1,500 pilots and airplanes to look after. And a 1,500 line database is fine. A 1,500 line spreadsheet is kind of slow, and that's at 1,500. If they're around another 3 years, what happens when it's 5,000? What happens when it's 10,000? What happens when they want to add users to another tab in their spreadsheet? If they want to keep track of ground users, add a ground users page to their spreadsheet. Now they're talking about ground users. They had 1,000 of those just in 2018. So it's going to quickly get out of control, and it's just going to be more than a spreadsheet can do. Whereas a database with relatively little computer hardware can handle hundreds of people running different searches and updates and deletes and modifications per second without too much trouble and without losing any data, without corrupting anything if the server crashes. Just all around a more resilient, a more reliable, and a more feature-rich data storage. And even though this is more complicated, yes, admittedly, to set up, to put your data in, we do have these nice graphical tools that we can drag and drop and point things with. So I'm going to show you how to use one of those in the next video to move a spreadsheet to a database by dragging and dropping, typing in fields, giving them names. It'll just be a matter of moving a structure over and setting it up in a reasonable way. And then you'll have your spreadsheet structure in the database. And once it's set up, it's, other than backups, it's a set it and forget it. The database is not going to need some person who's the ultimate authority on the master spreadsheets to constantly look after it and make sure nobody screws it up. It'll just be there doing its thing, running its searches and doing its calculations without any maintenance on your part. So, anyways, we're going to do that next, and do watch that before going into anything else in this channel. The biggest hurdle in all of this stuff is getting from the spreadsheet to the database and being able to set up your database in a reasonable way to catch all the data that you were catching in the spreadsheet. This is the only thing that stops people from using databases. These databases don't cost money. We're going to use one that's completely free. So the only thing stopping people from using these instead of spreadsheets is that first step, getting your data from the spreadsheet, something you can point and click into the database. So go through that more than once if you need to. Play with the tools a little bit, and once you've got database set up, um, you know, pretty well figured out in your mind, and you can do it without too much trouble, the rest of this stuff's pretty easy. So we'll see you in that video. Thanks.